Hi everyone, I'm Shubham Jhavar. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2021 Paper 1 Mathematics, and the question for this video is this. You may pause the video and read the question very carefully. As you might have seen the question very carefully, there is a clear feeling that we should be using telescopic series in tan inverse. Also note that in the options, everywhere we are talking about as x greater than 0. So that means where k is also some natural number, k varying from 1 to n, the summation is going on, k varying from 1 to n. So k is some natural number, x is positive, so that means this inside expression is positive. Yeah. So cot inverse of anything like this, we can write as tan inverse of reciprocal of that thing, given that that thing is positive. So here this expression is positive. So S and x we may write as sigma k equal to 1 to n tan inverse x by 1 plus kx multiplied by k plus 1x. So we'll be looking to create tan inverse alpha minus beta divided by 1 plus alpha beta sort of thing, so that we can create the telescopic series tan inverse alpha minus tan inverse beta, so to speak. So here in numerator there would be x, but I will smartly write it as k plus 1 times x minus kx, which essentially is x only. So here k plus 1 x is always positive because x is positive, k plus 1 is some natural number, kx is positive because x is positive and k is a natural number. So here you can write S and x is equal to sigma k equal to 1 to n tan inverse k plus 1 x minus tan inverse kx. Now coming to the first option, S of 10x. As you write for k equal to 1, k equal to 2, k equal to 3, so on and so forth up till k equal to 10, and you add, you would get S 10x as tan inverse 11x minus tan inverse x. So this essentially becomes tan inverse 11x minus x, that is 10x, divided by 1 plus 11x multiplied by x, that is 11x square. Now again 10x and this 1 plus 11x square, this whole expression essentially is positive. So you may write this as cot inverse 1 plus 11x square by 10x, which in turn you may write as pi by 2 minus tan inverse 1 plus 11x square by 10x. X is positive. So A is the correct answer. It is a multiple choice, multiple correct type question. Let's explore the option B. So here, as you go for option B, limit n tending to infinity cot of S and x equal to x for all x greater than 0. Let's explore. So here, S and x essentially turns out to be, if you see carefully, S and x will turn out to be, as you do the summation from k equal to 1 to n, you would essentially get tan inverse n plus 1x minus tan inverse x. It's a telescopic series, very easy to comment upon. So this you can very easily get. Now as n tends to infinity, S and x tends to, as n tends to infinity, S and x tends to, you may say, tan inverse of infinity times x. Mind that x is positive, so tan inverse of, indeed it is infinity and not minus infinity, or it's not something which we can't comment about. It is tan inverse of infinity, so to speak. So it goes to pi by 2 and tan inverse x remains as it is. Why? Because this term doesn't anyway depend on n. So now what about cot of S and x as n tends to infinity? Clearly it will be cot of pi by 2 minus tan inverse x. Pi by 2 minus tan inverse x is cot inverse x. Cot of cot inverse x is x. So this is also correct. Now coming to option C, S3x. S3x essentially will be what? Tan inverse 4x minus tan inverse x. Again x we are considering as positive. We are looking for root for x being positive, or we are looking for positive root of x. So for this to be equal to pi by 4, if you take 10 on both sides, you essentially get 3x by 1 plus 4x square equal to 1. That essentially means 4x square minus 3x plus 1 equal to 0. Now what about the discriminant? B square 9 minus 4ac minus 16. It's minus 7. It's negative. So discriminant being negative, that means it does not have any real root. What to speak of a positive root? It does not have even real root. So here C is incorrect. Now coming to D, we have to comment upon tan of Snx being less than equal to 12 or not for all n greater than equal to 1 and x greater than 0. Now if n is greater than equal to 1 is what we are talking about, I can even take n to be tending to infinity, in which case Snx, which we have already found out, tends to pi by 2 minus tan inverse x. So what about as n tends to infinity, what about tan of Snx? It essentially becomes tan of pi by 2 minus tan inverse x, or you may say tan of cot inverse x, which essentially becomes 1 by x. Now as x is greater than 0, and it's not necessarily taking only integral values, it can be anything, any real value greater than 0. So here tan of Snx as n tends to infinity, which doesn't violate this condition, which complies with this condition that n greater than equal to 1, this expression is 1 by x. And this can very well be greater than half and not necessarily less than equal to half. For example, you may even take x to be 1. X is greater than 0. X equal to 1 is greater than 0. So that essentially means D is also incorrect. And what we had to mark were the options which were supposed to be true, which are supposed to be true. So A and B are the answers. Thanks for listening. Stay tuned for the next question.